Okay, so if you're a senior architect working with Azure, you already know all of the buzzwords around observability. But how do you actually take it from theory and put it into practice? Well, think of this as your playbook for building a real-world strategic observability model, from those high-level business goals all the way through a live incident. Let's just jump right into the moment that matters most. Picture this: your most critical service is failing right now. Who finds out first? Is it your customers flooding support, or is it your own systems? And what exactly happens in the next 5 minutes? The answer to that question really defines the maturity of your entire operation. To even begin to answer that, we all need to be speaking the same language, and that language is the Service Level Objective, or SLO. Now, this is so much more than just a technical metric. It's the bridge, the direct connection between how your system is performing and what the business actually cares about. It's basically the contract between your engineering team and the business. All right, so with that foundation in place, let's look at the very first phase of our incident lifecycle. This is all the proactive setup, the stuff you do before anything goes wrong. We're going to move from our defined SLOs to creating actionable signals. And this is how you do it. It's a pretty simple 3-step translation. First, you and the business define a meaningful SLO, something everyone understands, like a 99.9% success rate for your main API. Then you set a threshold based on your error budget, how fast you can burn through that budget before it's a real problem. And finally, you just configure that logic as an alert in Azure Monitor. And just like that, you've turned a business goal into an automated signal. So all that prep work is done. Now we shift from being proactive to being reactive. All that preparation leads right to this moment. The system has spotted a problem, and the tripwire has been officially triggered. And there it is. The incident officially begins. A critical API latency SLO has been breached. The clock is now ticking. See, this isn't some vague email from a user saying, "The site feels slow." Nope. This is a specific, data-driven declaration that something is wrong. And that alert, well, that kicks off the human part of this whole loop, the on-call response. In the middle of a crisis, you don't want people getting creative. You want a calm, structured, and totally predictable process. And this is what that process should look like. Just notice how fast this happens. At time 0, the Azure alert fires. The on-call engineer gets paged automatically. Within 5 minutes, they're on it, and they've already started a runbook. By the 15-minute mark, a pre-planned fix is being applied. And in under 30 minutes, the service is stable again. This isn't panic. This is a well-rehearsed drill. Now, how can they move that fast under pressure? It's because they aren't guessing. They're following a runbook. You can think of this as the on-call engineer's emergency checklist. It guides them through every step. Acknowledge the page, check the right dashboard, look for any recent deployments, and, most importantly, execute a specific script to fix it. It takes all the guesswork out of a super stressful situation. Okay, so while the engineer is deep in the weeds, in the command line, leadership needs a completely different view. We need to zoom out, way out, from the technical details to the strategic dashboard. And this is what that view looks like. It's clean, it's simple, and it speaks the language of business impact. Nobody here's asking about CPU utilization. They're asking the important questions. Are our services healthy? Are we hitting our targets? And what is the real impact on our customers? Right here, we can see our inventory API is degraded. It's at risk, and it's causing latency for about 15% of our users. That's actionable information for stakeholders. So, the service is restored. The dashboard is all green. We can all relax, right? Not so fast. The work isn't over. You see, the incident itself isn't the most valuable part of this process. It's what you learn from it afterwards that truly matters. This is where you turn a failure into an investment. The post-incident review is not about finding someone to blame. It's about asking how we get better as a team. Did we have enough data to find the root cause quickly? Did our runbook actually help, or does it need to be updated? And then, the biggest question of all, how do we prevent this entire class of failure from ever happening again? And that kind of thinking leads us to the final and, I think, most important step. This is where you move from seeing observability as just a tool for responding to incidents to making it a core part of your engineering culture. So how do you make that real? You bake these questions right into your process. Before a single line of code is even written for a new feature, your team is already asking, what are the SLOs for this? How are we going to know it's failing before our customers do? Is it instrumented with the right telemetry? And is there a runbook for when it inevitably breaks? You start treating observability as a first-class feature, not an afterthought. Because ultimately, a mature observability practice isn't really about being the fastest firefighter. It's about being the best architect. It's about building systems that are not only resilient, but are also transparent and understandable from the inside out. So I'll leave you with this one question to take back to your teams. I want you to look at your tools, your dashboards, your entire process, and ask this. Are you just monitoring for failure, basically waiting for red lights to flash? Or are you truly observing your systems with the goal of deeply understanding how they work? Because that difference, that's everything.